Assalamu alaikum. How are you today? I'm going to update my chats. Let's see whether we can see anything interesting today. Right, I'm going to update cases per day for Malaysia. It seems like the largest that we've got was on 26th of March, within the past 1 week. The number was 235 cases on 26th of March. I tried to put a trend on this chart. The trend I've used is polynomial, and it's actually to a degree of 6, okay? And the regression, the R squared, is actually 88%. If you look at this curve, this is actually tending downwards. What that means is that this polynomial is trying to accommodate all these figures, all these numbers, but it may not be signaling the reduction of the cases. Is how the curve trying to fit into the bar graph. So I wouldn't rely on this. I'll explain why a bit later on. As for Australia, it looks like it's reducing in a bit. The largest number was 460 cases on 28th of March. And if I try to add in the trend line, it's showing a curve which is downwards after 27th of March. It seems like maybe it's going to reduce, but this is only approximation of polynomial of degree 6, and the regression R squared is about 0.96 or 96%. Fitting the curve on a chart is actually easily done by any calculus students, high school calculus students. It's pretty standard, it's pretty easy for them to do it. But predicting the behavior of the infections is actually modeled by some epidemiologists around the world. In fact, there's some equations where you can model this spread of the virus. Some of them, namely, is called SEIR, susceptible, infected, and recovery. Some use logistic curve. So if I've got time, I'll just go through them very quickly, maybe today or maybe next time. I'll try to explain this briefly a bit later on. Now I'm trying to update comparison between Malaysia and Australia in terms of cumulative cases. As you can see here, on the 30th of March, Australia has got 4,250 cases and Malaysia has got 2,626 cases. Both countries have imposed some sort of restriction of movement. Okay, for example, in Australia, the government has issued restrictions on large gatherings on the 18th of March, and Malaysia has imposed MCO, Movement Control Order, on the same day, 18th of March, which was on Tuesday, 2 weeks ago. On this graph, you can see also the line which I've drawn on the 18th of March. This vertical line is actually where the government of both countries imposed the restrictions on movement. The yellow line, horizontal yellow line, is actually indicating the critical number for Malaysia, which is 3,585 beds. So if the cumulative cases exceed 3,500, it's going to be cause for alarm for Malaysian authorities. How strong are these policies? We will only know once the COVID virus is actually reduced significantly, which can be within the next 1 month or 2 months and so forth. JP Morgan is saying that in Malaysia, for example, the highest peak is going to be in mid-April. So after that, it's going to go south. I've also plotted, just out of interest, of Malaysia and Australia daily cases on the logarithmic chart. The red curve is actually a Malaysian curve. What's interesting is that if I just put in straight line, you can see on this logarithmic chart, if I look at 10 days period from 29th to 10, for example, the case actually 10 times increase, okay, in terms of number of cases. And from 10th of March to 20th of March, it's another 10 times increment. However, round about 25th of March, you can see that the curve has started to deviate from the slanted straight line, which implies that probably the cases has been stabilized. It doesn't really mean that it's not going to be reduced, but it's been stabilized somehow. Will that be because of the imposition of the movement control order? I have no idea. It could be because of that, or it could be some of the reasons that we don't know. In the meantime, I've already completed the SEIR modeling, susceptible, infected, and recovery model. I've tried to actually simulate the Wuhan population, so the equation that I've been trying to use. I just want to show that it's going to be very interesting. So what I've done, I've simulated this, I've got the right equation. I'm going to use this for Malaysian situation. I've drawn the curve for Wuhan, SEIR simulation for Wuhan. That's in terms of number of susceptible population and number of days. And it's this rate curve here, this infectious rate that we are worried about, and this is a peak, okay, within 10 days or 25 days of Wuhan. And I've done the same thing for Malaysia, and this is going to be the chart for Malaysia. I don't know whether it's going to be real or not. I just want to see whether what JP Morgan has done is similar to what I've done. I can't really understand whether the population used by JP Morgan is different than mine. Maybe there's some things that I don't know about epidemiology. So anyway, I'm going to share this video later on. Okay, hopefully before the peak time as predicted by JP Morgan. Okay, so that's it for today, and I'll be updating you guys again hopefully sometime next week, inshallah. Thank you for watching.